Hello everyone, I am Alok Kumar and I welcome you to the first lecture in the two-lecture series on trigonometric equations. So let me now quickly share my screen with you all and start the lecture. Okay, so the first thing that we start is how to write the solutions of trig equations, which I am telling like this, that sine theta is k. Suppose you want to solve -1 less than equal to k less than equal to 1, of course. Otherwise, it does not make sense. Similarly, cos of theta equal to k with the same bounds, and tan of theta equal to k. But this time, k is allowed to take all real values, that k belongs to R. These are three fundamental equations which we propose to solve and use. Already, you have got some idea. As a revision, let me tell you some key points. First of all, when you are given sine theta is k, we find some angle alpha element of R, such that sine alpha equals k. Mind you, alpha can be any number. It need not be always principal value. Means alpha can be any real number satisfying 1. So the moment we have got this, then it means we are solving sine theta is sine of alpha, and that happens to be theta is n pi plus -1 whole to the power n raised to the power n and times alpha. That's called its general solution, and that's for sine theta is sine alpha. I again remind you that if you are given sine theta equal to say 1/2, you could take any of them. Sine theta is, you can take sine, this is 30, so this you can take sine pi/6. You may also take sine 5 pi/6. Anything works as long as it's equals half. But I would recommend this one because angle is smaller. Otherwise, theory does not tell anything about it. So sine theta is sine alpha is this. Similarly, if you have got cos theta is cos alpha, and again alpha can be thing, you can have theta is 2n pi plus minus alpha as the general solution. And if tan theta equal to tan alpha, then you have theta is n pi plus alpha. These all can be derived easily using transformation formulae, which of course you have done. So I'm skipping that in the revision. Just we are saying that, okay, this equals this. Now, important point is this, that if you have sine theta is 1, or sine theta equals -1, or cos theta is cos theta is 0 and cos theta is -1, then you need not consider the full thing. For example, sine theta is 1 by formula will give you sine theta is sine pi/2. So theta is n pi plus -1 to the power n and pi/2. That's fine. We can write like this. But because this -1 has come, I have to take cases. So let's take n is even. That is n is 2m and n is odd. So let's say n is 2m plus 1. 2m minus 1 also works. So n is 2m, this is even. Then in this case, theta happens to be 2m pi n plus pi/2. In the case of 2m plus 1, you get 2m plus 1 times pi and this negative pi/2. That again gives you 2m pi plus pi/2. Means that if sine theta is 1 special value, then you need not use this one. Don't use this for this case. Rather, directly use that sine theta is 1, then theta is 2n pi plus pi/2. That formula simplifies, and this is what we will stick with. Similarly, if sine theta is -1, I'll get theta is 2n pi minus pi/2, and of course n element of z, that is n is a integer, and this can be either negative or positive or 0 as integers are. So this is simplifying in case of sine theta equal to 1, sine theta equal to -1. For all other cases, go ahead and do the same thing. It does not matter. Similarly, if you have got cos theta is 0, then your result tells you that theta is 2n pi plus minus alpha. So because you know that cos 0, this is cos pi by 2. So we'll write 2n pi plus minus pi over 2. But then, if you do like this, look at here, 2n pi plus minus alpha, 2n pi plus minus alpha. So if I write theta is 4n plus minus 1, or let me take even and odd. So I will have to get this. And then I can simply write that theta equal to 2m plus 1 pi over 2. 2m plus 1 pi over 2. Why we can write like this? Because we can again take cases and we will get that theta is 2m plus 1 pi by 2. Means if cos theta is 0, then I don't care. I can just write like this. Similarly, if cos theta equal to negative 1, then formula tells you theta is 2n pi and plus minus pi. But 2n plus 1 and 2n minus pi, they are both odd only. No such difference. Both cover all odd numbers, and so I can just take theta is 2n pi plus pi without losing any solution. So this we will always be using in such cases, that special cases, this kind of thing. So let's see that how we can use them to solve some problems. So first is that we will solve things by, say, transformation, or say reducing into polynomial. Reducing to polynomial. Now, say for example, I have got cos theta, cos 2 theta, cos 3 theta is 1 over 4, and I want to find number of solutions, because normally J gives you this only number of solutions in, say, interval 0 to 2 pi, both closed. I want all those numbers theta which satisfy this, and they lie in 0 to 2 pi, both inclusive. The moment we see cos A cos B, we would like something to do with 2 cos A cos B. So motivation will be that I'll start writing, so I will write 2 cos theta and cos 2 theta, cos 3 theta is 1 over 2. Now, it makes sense to pair off cos theta with cos 3 theta, because we expect that cos A minus B will come and cos 2 theta is there. So symmetrically, 2 cos theta, cos 3 theta, n times cos 2 theta equals 1 over 2. And 2 cos A cos B I can write as cos of A minus B and plus cos of A plus B. So cos of 2 theta plus cos of 4 theta times cos 2 theta is 1 over 2. This we can write. And once we do that, we can again multiply by 2, and we can write 2 cos square 2 theta and plus 2 cos 4 theta cos 2 theta equal to 1. I can also write 2 cos square 2 theta minus 1 by bringing this side, and plus 2 times cos 4 theta cos 2 theta is 0. And this number, this expression becomes cos of 4 theta. So cos 4 theta plus 2 cos 4 theta times cos 2 theta is 0. I can take out common cos of 4 theta, and I'm left with 1 plus 2 cos 2 theta is 0. So that gives you cos 4 theta is 0, or cos 2 theta is negative 1 over 2. We know just now we want to solve all of them. So cos 4 theta is 0 means 4 theta as odd multiple of pi over 2, 20% pi over 2. And similarly here, cos 2 theta is minus 1 over 2. So we write 2 theta is, because this number I can write is cos of 2 pi over 3. And so we can write 2 theta is 2n pi plus minus 2 pi over 3. One word of caution, I am using same n, but they are independent. If there is some confusion, you can always use different symbols, say m and n. That is just a warning. If you feel comfortable, keep using both n, but remember, they will take value independent of each other. So this theta will give you n pi plus pi over 8, and this theta gives me n pi and plus minus pi over 3. So from the first family, if I come from the first family, then I can write all the solutions, and we have got 2n plus 1. No, this is actually 2n plus 1 pi over 8. So I erase that. This is theta is 2n plus 1 times pi over 8. And so when you put values, because we want, let's look at the problem. We only want from 0 to 2 pi. So first circle 0 to 2 pi. So this is your pi over 8, and then 3 pi over 8, and 5 pi over 8. All the way you will go 7 pi over 8, then 9 pi over 8, 11 pi over 8, 13 pi over 8, 15 pi over 8. You can stop here, because now the next one, 17 pi by 8, and all these, they are now not this one. They will just be outside 2 pi, so they are not included. So we can stop here, and this is 1 2 3 4 5 6 7 8. So you have got here 8 values in the interval. We could also have got easily this by saying that we want 0 to 2 pi. So 0 less than equal to 2n plus 1, pi over 8 less than equal to 2 pi. We want this kind of thing. So let's solve for this one. So 0 less than equal to 2n plus 1 less than equal to 16 we want, and an integer. So n start from 0, and n goes the way, n cannot be 8, n goes all the way to 7. So 0 1 2 till 7, that gives you 8 values. We have just listed those values explicitly, although it was not needed. In exam, we will just do this step. We will find that how many values are there. So n equal to 8. So 8 values are there from this case. Come to this case, they have got two family of solution, n pi plus pi over 3, and other is n pi minus pi over 3. So let's put here n is 0, so pi over 3, and n is 1. If I put n is 1, then we will get something. So you will get here 4 pi by 3. So this is 4 pi by 3. N equal to, if you put 2, it exceed. So you can't put here. N is 1, because 0 you can't put negative. So this is 2 pi over 3. And n equal to 2, then you will get 5 pi over 3. And so we have got 4 more solutions here, 4 more. And so totally we will say that number of solutions in 0 to pi of this equation is, number of solutions is 12. So normally you have got this kind of answers in JEE Advanced multiple choice questions, that the number of solutions is. So this was based on transformation. Essentially we transformed the same thing. Notice here, notice cos 2 theta. When you got this step, so let me copy this step, 2 cos square 2 theta. So when somebody gets to this second solution, so if somebody gets to the step 2 cos square 2 theta, this stage, 2 cos square 2 theta plus 2 cos 2 theta and times cos 4 theta equal to 1, it is natural that he will try to reduce this as a polynomial in cos 2 theta. So let this put equal to t, cos 2 theta is t. If that is the case, we will get here 2t squared. So you are getting 2t squared plus 2 cos 2 theta, that is 2t, and cos 4 theta is 2 cos square 2 theta minus 1. So 2t squared minus 1. So I can write 2t squared minus 1. And this number now, let's check our calculation. So this number now becomes 1. And so you are getting 4t cube. This is 4t cube. So you will get 4t cube and then plus 4t squared and then minus 1 equal to 0. Let's check our calculation. This is 2t squared. So this is 2 cos 2 theta. That's here 2 cos squared 2 theta. So 2 cos squared 2 theta plus 2 cos 4 theta times cos 2 theta equal to 1. So we are getting 2 cos squared 2 theta. That is 2 times t squared. So 2 times t squared. And then this is your 2 cos 4 theta 2t and then 2t squared minus 1. So you will get this kind of thing. And then again by the similar logic we can solve for t and we can get our equation and we can get our solution. So we can solve in both forms. It just needs to be careful about the calculation and then you can do rest of the work. Next is this one. 1 minus tan theta times 1 plus sine 2 theta is 1 plus tan theta. So the moment you see something like that, then your first thought is that can I express everything in terms of a single variable? You are not disappointed because you remember that sine 2 theta equals 2 tan theta upon 1 plus tan square theta. So it so happens that 1 can be written in terms of tan theta. So let's set tan theta equal to t. Then you get 1 minus t, 1 plus, that is 2t upon 1 plus t squared is 1 plus t. Let's keep it like this. So 1 minus t, and this is 1 plus t squared plus 2t, that is 1 plus t whole square in the numerator, and 1 plus t squared is 1 plus t. So I can bring everything to the left side, or I can multiply by 1 plus t squared. So I write 1 minus t, 1 plus t squared is 1 plus t times 1 plus t squared. It's looking the form of polynomial. So now if you bring everything to the left side, this is 1 plus t whole square minus 1 plus t. 1 plus t squared is 0. I take 1 plus t common. You get 1 minus t times 1 plus t. Negative 1, negative t squared subtracted is 0. So you're further getting 1 plus t times, this is 1 minus t squared minus 1 minus t squared equals 0. And so ultimately it becomes 1 plus t, and this is t squared equal to 0, because negative 2, of course, 2 cancels because this is 0. So t equal to 0. T square is 0 means t equal to 0, or t equal to negative 1. Now so t equal to 0. Now t equal to 0 means it was tan theta. So tan theta is 0. And also you have got tan theta is negative 1. If tan theta is 0, then theta is n pi. If tan theta is minus 1, I can write this is tan of minus pi over 4. And so I'll get theta is n pi minus pi over 4. So you have got two families of solutions. So we have got one family as n pi, one family is n pi minus pi over 4. And as usual, n element of G, that is n is 0, plus minus 1, plus minus 2, and all those integers. So here we used that transform into polynomial. So either we will transform using sine cosine rule, or product to sum, or those things. Let's look at our next example. So that's little involved. You want to solve 2 cos x plus cos 2x plus sine 2x times 1 plus 2 cos x is twice of sine x, and you want minus pi less than or equal to x less than equal to pi. Means you want to capture all solutions which lie in this interval, 2 cos x plus cos 2x of this one, minus pi to pi. Lots of sums are there, cos c plus cos d, and then this also I can break sine 2x plus 2 sine x cos x. So let us start 2 times cos c plus cos d, that is 2 cos c plus d over 2. So c plus d over 2, cos c minus d over 2, cos x over 2. I write this is sine 2x and plus 2 times sine 2x cos x equals 2 sine x. I can further break them up, 2 sine a cos b. So we are going from product to sum and sum to product whenever it is possible. Now 2 sine 2x and cos x. If this I write 2 sine a cos b, so sine of a plus b, and plus sine of a minus b, so that becomes plus sine of x. Now this number is becoming 4 cos x by 2 cos 3x over 2, and then plus sine 2x plus sine 3x, and once you bring this to this side, you are getting negative sine x equals 0. That's so good. We can still do some more thing. So this time I can combine sine 3x minus sine x, because that also may give you some product, or I may combine sine 2x plus sine 3x. That depends. If I do sine 2x plus sine 3x, I may be better placed, because this will give me 2 sine c plus d over 2, so sine 5x over 2, and cos of x over 2. And notice that sine x also, by half angle formulae, breaks as twice sine of x over 2 times cos over x over 2 equal to 0. So we have a factor cos x by 2 running all over. So that's good news that we can bring them out, that cos x by 2. So I can bring 2 cos x by 2 out. So I'm left with 2 cos 3x over 2. Collect all the terms carefully, and then plus sine 5x over 2, because these two already have collected, and negative, this is 2 cos by 2 is gone, so this is sine x by 2 equal to 0. Now I can again apply our result to this one, sine c minus sine d. So I can write 2 cos x over 2, 2 cos 3x over 2, and sine c minus sine d, that's 2 sine c minus d over 2. So 5x minus x corresponds 2. So this is sine of x, simply sine of x. And then this is cos of c plus d over 2. So that is cos of 3x over 2. And so that is just equal to 0. Again, cos 3x by 2 is common. This cos 3x by 2 cos plus 2 common. So that good news. So cos x by 2 and 2 cos. So this is 2 into 2 cos 3x over 2. And then I'm left with 1 plus, and then sine x equals 0. And then we have got 3 factors. So these all sum. Notice how carefully by applying transformation, nothing else, only transformation, means sin c plus sin d formulae, like sum to product or product to sum. We have been carefully doing that, and last we are left with these kind of 3 factors. Their product is 0, and so each of them is separately 0. So this is cos x by 2 is 0, or cos x by 2 is 0, or sin x equal to -1. Cos x by 2 over 0, that gives you x by 2 is 2n plus 1 pi over 2. So that is x is 2n plus 1 pi. So that's our one solution, family of solution. 3x over 2 is 2n plus 1, and then pi over 2 again. And this time you get x is 2n plus 1 pi over 3. And then the next is sin x. So x is 2n pi, we did it, minus pi over 2. So you're getting x is 2n pi minus pi over 2. We want solution only from minus pi to pi. So let's put here this. Here I can put n equal to, say, -1. So n equal to -1 will give you negative of pi. N equal to 0 will give you pi. Both must be there because we want to find minus pi to pi both inclusive. So minus pi pi from this family. From this family, if I put n equal to -1, I'll get minus pi over 3. That's allowed. If I put n equal to -2, it goes out. N equal to 0, if I put, it's still pi by 3, allowed. And then here, if I put n equal to 1, it's not working. N is 0, minus pi over 2. -1 I cannot put. And so you have got these 5 solutions. So you have got these 5 solutions in the interval minus pi to pi, and that's our answer, that number of solutions in minus pi to pi. So these examples were based on transformation, and then we also did that how to turn it into a polynomial. Other special thing transformation is of the form a cos x plus b sin x equal to c, where a, b, c are some real numbers. So first observation, that for x to for this equation, for it to has, so it has solutions. If it has solutions, implies that first of all mod c must be less than equal to root a square plus b square. That we can see because let's write a cos x plus b sin x over root a square plus b square is c upon root a square plus b square. So c upon root a square plus b square, by choosing suitable values, I can transform them to sine of x plus alpha or cos of x plus alpha, anything. And because we know that this mod, we know that mod of sine theta less than equal to 1. So we'll get mod of c upon root a square plus b square less than equal to 1. So mod c less than equal to root a square plus b square is a condition which is both necessary as well as sufficient for the equation a cos x plus b sin x equal to c to have real solutions. So to have real solutions, this must be satisfied. And once that is satisfied, we can always divide by root square b square and we can solve. So we will take one example based on this. So sin x plus root 3 cos x equal to root 2, we want to capture all solutions. So we divide by 1 square plus root 3 square, a square b square. That is your 4. And this is, if you take root, so root of 4 becomes 2. So we are saying that divide this by root of 1 square plus root 3 square. And we will do just thing here also, that is 2. So you will get here 1 by root 2, 1 by 2 times, so let me do this one, that this is 1 over 2. So 1 over 2 sine x plus root 3 by 2 times cos x is 1 over root 2. Now, one word of advice, I can write this one as either cos, this is half, so cos 60. So I can write cos pi by 3 sine x, and then I have to write here, I cannot change, already have made a mind, so sine 60 sine pi over 3 cos x is 1 by root 2. Or I can write this as, this is in terms of sine, I can write sine pi over 6 sine 30 and sine x, and plus cos pi over 6 and cos x equal to 1 over root 2. In two of them, I will prefer this form, because that will give me pi plus negative 1 to the power n alpha. And if you have cos theta is cos alpha, I have theta is 2n pi plus minus alpha. So if the choice is between minus 1 to the power n and plus minus, this is preferable. And so always I will write this in terms of cos and not in terms of sine. Although, of course, as expected, you will always get the same answer. That's, of course, maths cannot be wrong. So now cos of x minus pi over 6. So I will solve in this form. Cos of x minus pi over 6 is 1 over root 2. Now that number 1 over root 2 is 1 over, this is just, let me just use this, pi by 6. So this is, I will write cos of pi over 4. And so I can write x minus pi over 6 is 2n pi, and this is plus minus pi over 4. So if I take plus 4, so x is 2n pi plus pi by 4 and plus pi over 6. And other family of solutions is 2n pi negative pi over 4 and plus pi over 6. That gives you 2n pi plus this 12 is the LCM. And so you will get 5 pi over 12. And here you will get x equal to 2n pi, and this is 6. That is, you will get minus of pi over 12. So that is your answer for these two cases, that you are getting these two as solutions. Let's continue further by one more example that calls this one, that if you have got expression of the form sin x plus minus cos x and sin x cos x equal to 0. So if you have got a trigonometric equations, which have got these expressions, then consider substitution sin x plus cos x is t, or sin x minus cos x equal to t, as the case may be, depending on the case. So as the case may be, you can go for the substitution. So one example will be in order that you want to find 0 to pi. In 0 to pi, you find all solutions. So you find all solutions of, this is sin 2x minus 12 sin x minus cos x plus 12 is 0. So you want to find this solution. This will reduce to the previous case, as we will see. So first we will write sin x minus cos x equal to t, because this appears. Once we squared, you are getting 1 minus sin 2x is t squared. And so sin 2x is 1 minus t squared. Then 1 reduces to, that is 1 minus t squared minus 12, that is t, and plus 12 equal to 0. So you are getting t squared and plus 12, changing the sign, negative 13 is 0. And this t equal to 1 is a root. So we can say clearly that t minus 1 and other root is this one. So t plus 13 is 0. Factorizing. So t is minus 13 not possible, because t is sin x minus cos x, which we know is from minus root 2 to root 2. So that's not possible. So t equal to 1. So that is sine x minus cos x equal to 1. So I can use the thing that I started with. So I can divide by 1 by root 2. So 1 by root 2 sine x minus 1 by root 2 cos x is 1 over root 2. I prefer sine to cos. So this I will write as sine pi over 4 and this as cos pi over 4. So I have got sine A sine minus cos A cos B. I can write cos A cos B. So cos x cos pi by 4 minus sine x sine pi over 4 is negative 1 upon root 2. Now cos A cos B minus sine A sine B gives cos of A plus B. So cos of x plus pi over 4. This is minus 1 over root 2. That is cos of 3 pi over 4. Cos pi by 4 is positive. 3 pi by 4 of course is negative. So there is 3 pi by 4. And now solution is x plus pi by 4 is 2n pi plus 3 pi by 4. Or it can be 2n pi minus 3 pi over 4. From the first family, we get x equal to 2n pi, and this is minus pi. And from second, we get x is 2n pi, and minus 3 pi 4 plus minus this is this family. And from this family, we are getting 2n pi plus pi over 2. Now, I just put the value. So if I want to get in the interval 0 to 2 pi, it is here 0. I want 0 to 2 pi, 0 to 2 pi, the solution. So it means here now, if I put n equal to 1, I get pi, no other solution. If I put n equal to 0, I get pi over 2. N equal to 1 exceeds, other thing exceed. So I have got just two solutions, pi by 2 and pi in this expression. I can also solve from here because 1 is there, 1. So I can also solve in a separate way. So let me change the color and just illustrate that the other way. That is because x is there, 1 is there, I can write sine x minus 1 plus cos x equal to 0. Sine x is 2 sine x by 2. Cos x over 2 minus 1 plus cos x is 2 cos squared x over 2 is 0. I can take common 2 cos x over 2. That is sine x over 2. And then minus cos x over 2 is 0. So either cos x by 2 is 0. In that case, I will get x by 2 is 2n plus 1 pi over 2. So that is x equal to 2n plus 1 pi. And that we got indeed 2n pi plus pi, that we can check. It is 2n pi minus pi. I told you both are same because this is 2n minus 1 pi and 2n plus 1 pi, no difference because both are odd integers. They can take all integer values, odd values. Next, come to here. Sine x by 2 equal to cos x by 2. I can divide by cos x by 2 as cos x by 2 is 0 is not a solution. So I can divide and it is equivalent to tan of x by 2 equal to 1. That is x by 2 equal to n pi n plus pi over 4. That is from tan. And so I can get x is 2n pi plus pi over 2. They of course are in agreement as they should be. So this also is one method when especially 1 is there. If not, we can keep dividing like this. One example which makes use of an identity also, it's more polynomial, is this. Solve 1 plus sine cube x plus cos cube x is 3 by 2 times sine 2x. Now this is power is much more and there is no common factor. So you cannot put say sine x equal to t because cos x also occurs. If sine x is t, then cos x will be either root 1 minus t square or negative. And that's quite ugly because it is cube also. So think of this as two variable. If you think of this way, that this is, say, first write 1 plus lot of cube is there. So 1 cube plus sine cube x plus cos cube x. I expanded 2 sine x cos x. So that is 3 times sine x cos x. So it's like 3 times 1 times sine x times cos x. Now definitely this is quite familiar with you. You can read here, it's like a cube plus b cube plus c cube. This seems to be telling equation is 3 times abc. Now that's something really beautiful, really interesting, and on which you have solved a lot of problems. So a cube plus b cube plus c is 3abc. I can factorize, and so if I bring this side, so trigo will come later. Now is the turn of algebra equal to 0. Then I will get a plus b plus c n times a squared b squared c squared minus ab minus bc minus ca equal to 0. Now this number still I can write as half of a minus b whole square, b minus c whole square, plus c minus a whole square. and and so this is 0 means either a plus b plus c is 0, or second factor is 0, but all are real numbers. Second factor is 0 means a equal to b equal to c. Now you are good. Either all the variables are equal, or the sum of all of them is 0. So now we have got a as 1, b as sin x, c is cos x. So for this to be satisfied, either 1 plus sin x plus cos x equals 0, or 1 equals sin x equal cos x. Obviously, because sin square x plus cos square x equal to 1, this cannot hold, because both cannot be 1 at the same time. And so this is not possible. The only possibility is sin x plus cos x equal to minus 1, which, as I have told you, I can again still solve using the two methods above. So I just choose this method. So I'll write here sine of x and plus 1 plus cos x equal to 0. So we'll write 2 sine x by 2 cos x by 2 plus 2 cos square x over 2 is 0. I will take common 2 cos x by 2. Sine x by 2 plus cos x by 2 is 0. So either cos x by 2 is 0, or sine x by 2 is negative of cos x by 2, which we can divide by cos x by 2 because it is not 0. So it is equivalent to tan of x by 2 equal to negative 1. And so this gives you x by 2 is 2n plus 1 pi over 2. So x you get as 2n plus 1 pi. So 2n pi plus pi. And in this case, you are getting x by 2 is n pi minus pi over 4, because negative 1 is tan of negative pi over 4. And so x you will get as 2n pi minus pi over 2. So these are your two families of solutions. And this is what you will get if you are to solve this. Next is a little different thing. So they are saying let alpha and beta be two distinct values. So be two distinct values in theta element of 0 to pi, or of such that 3 cos theta plus 4 sin theta equal to 2, and theta element of 0 to pi, and we are saying that they are distinct, means alpha is not beta, satisfying this one. Your goal is to find out sine alpha plus beta. So you want what is sine alpha plus beta if alpha and beta be two distinct values of this expression. Now they are not asking to solve it, you just have to find some expression. So better would be that I write that 3 cos theta plus 4 sin theta equal to 2 has roots alpha and beta, means 3 cos alpha plus 4 sin alpha is 2, and also 3 cos beta plus 4 sin beta is 2. I can subtract one from the other, so that gives me 3 cos alpha minus cos beta, and plus 4 times sin alpha minus sin beta equals, this is 0. Now I can apply transformation. So 3 times cos c minus cos d, that is 2 sin c plus d by 2, and sin d minus c by 2, that is beta minus alpha over 2, and plus 4. So 4 times 2 sin c minus sin d, sin c minus d by 2, and cos c plus d by 2 is 0. I can take common twice, and sine of alpha minus beta by 2. That means here I will get negative 3 sine of alpha plus beta by 2, and 4 cos alpha plus beta by 2 equal to 0. So I get this number. Now sine alpha minus beta by 2, as alpha and beta both belong to 0 less than alpha beta less than pi, we know that alpha minus beta is from minus pi to pi, and alpha minus beta, this is minus pi to, this is 0 to 2 pi, 0 alpha beta less than 2 pi. Let's make a small correction, that this is not pi, this is 2 pi given, this is given to be 2 pi. And so you will find that alpha minus beta So this is alpha minus beta. That also comes from minus 2 pi to 2 pi. And so alpha minus beta by 2 is negative pi to pi. And distinct numbers. So alpha minus beta by 2 is not 0. And we want sine of alpha minus beta by 2 is 0. This is not possible because sine theta is 0 means theta is n pi. That is theta is minus pi, 0 pi. Nothing is allowed. So these are not possible. Others not given only. It means this factor is never 0. So first factor is never 0. We write that sine alpha minus beta by 2 is never 0. And so from here you will get that 3 sine alpha plus beta by 2 is 4 cos alpha plus beta by 2. And so I can get tan of alpha plus beta over 2. And that number is tan of alpha plus beta by 2 is 4 over 3. So from tan theta, I can get, of course, sine 2 theta. So sine of alpha plus beta, that happens to be 2 tan alpha plus beta over 2, and upon 1 plus tan square alpha plus beta over 2. That is, you're applying sine 2 theta is 2 tan theta upon 1 plus tan square theta. That number becomes 2 into 4 over 3 and 1 plus 4 square by 3 square. So that becomes your that 24 and upon 25. And so that's my answer, 24 upon 25. That's your answer for this one. Let's see an application to exponential equation, which is again reducible to quadratic. And that goes like that 3 to the power sine 2x plus 2 cos square x and plus 3 to the power 1 minus sine 2x plus 2 cos square x, and this equals 2. It is 2 sine square x. So let me change that. So this is 2 sine square x. So that's 2 sine square x, and that equals 28. I want to solve for all x. General solution I want. So notice that it is sine 2x plus 2 cos square x. So I can write 1 minus sine 2x, the other exponent, sine 2x plus 2 sine square x, in terms of 1 minus sine 2x plus 2 1 minus cos square x. So I can write 3 minus sine 2x plus 2 cos square x. Means the sum of this number and this all, that sum is of course 3. Now if I take 3 to the power sine 2x plus 2 cos square x equal to t, some variable t, then my expression 1, then 1 implies 3 to the power sine 2x plus 2 cos square x plus 3 to the power 3 minus sine 2x plus 2 cos square x equal to 28. That is 3 to the power sine 2x plus 2 cos square x plus 3 cube upon 3 to the power sine 2x plus 2 cos square x equal to 28. If I take this as t, I'll get t plus 27 over t equal to 28. So it is ultimately a quadratic. So I'm getting t square minus 28t plus 27 is 0. So t minus 1, t minus 27 equals 0. I get t is 1 or t is 27. Now let's take the case when t equal to 1. In that case, 3 to the power sine 2x plus 2 cos square x. So sine 2x plus 2 cos square x is 1, is 3 to the power 0. And so I am getting sine 2x plus 2 cos square x is 0. That is 2 sine x cos x plus 2 cos square x is 0. That is 2 cos x common. I am getting sine x plus cos x equal to 0. Cos x is 0 gives you x equal to 2n pi plus pi over 2. and sin x plus cos x equal to 0 means that gives you tan x equal to -1, and so you're getting x equal to n pi minus pi over 4. That is one family of solutions. Next, come to this one, that when 3 to the power sine 2x plus 2 cos square x is 27, that is 3 cube. So we get sine 2x plus 2 cos square x equal to 3. Now we know that sine 2x less than equal to 1. Of course, sine 2x greater than equal to -1, but we don't need it, so I will not use it. And here, cos square x less than equal to 1. So 2 cos square is equal to 2. And when you add, you find that sine 2x plus 2 cos square x less than equal to 3. It means 3 is given, so equality holds throughout. So we get sine 2x equal to 1, and we get 2 cos square x equal to 2. That is cos square x, or that is 2 cos square x. I can write as 1 plus cos 2x equal to 2. So I can get cos 2x equal to 1. Now cos 2x equal to 1 and sin 2x equal to 1, we have just seen in one of the examples that they are not possible at the same time. And so in this case, you get no solution. So this answer is no solution. Notice carefully how the problem was as exponential equation, and then two from trig equations, and in between you have got quadratic also, small quadratic. So normally this kind of questions will come. So they are based on this one, what we call inequalities or extreme values, which are very relevant for IT exam. One basic question of this regard is this one: sine 6x plus cos 4x plus 2 equal to 0. You should try to see how I obtain the solution, because this is extremely important. Now first I write that sine 6x plus cos 4x equal to -2, and we are arguing that sine 6x greater than equal to -1, cos 4x greater than equal to -1. And of course it is also true that less than equal to 1, but I don't need it, so I'll not use it. Now this means that when you add them up, sine 6x plus cos of 4x greater than equal to -2, but given to be exactly -2, it means all of the inequalities must be in fact equalities. And so I will get sine 6x is -1 and cos 4x is -1. Okay. Now sine 6x is -1. So I can solve it. And I will get 6x is 2m pi minus pi over 2. Remember, minus pi over 2. And I will use different symbol. So 4x will be 2n pi plus pi. So I use this one. Mn both are integers. Now I want common value of x. This is very important example, common value of x. So I will just equate. So from 6x is 2m pi minus pi over 2. I'll write 12x is 4m pi minus pi, and 4x equal to 2n pi plus pi. I'll write 12x is 6n pi plus 3 pi. Instead of dealing with fractions, I am using this one. Now these two must be equal. So 4m pi minus pi equals 6n pi plus 3 pi. That gives you 4m minus 1 is 6n plus 3. That is 4m minus 6n is 4. And that I can write 2m minus 3n equal to 2. So see that you want mn element of G integer, m equal to 1, n equal to 2. That is n equal to 0. 1, 0 is a solution. 1, 0 is a solution. So I can write 2m minus 3n is 2 into 1 minus 3 into 0. That is 2 times m minus 1 is 3n minus 0. And so I can write m minus 1 is 3k and n minus 0 equal to 2k. That is m is 3k plus 1 or n is 2k. I can use anything I like. So let's use first one. So x was this much. So 6x was this much. So 6x was your n pi minus pi by 2. So I can write 6x is 2m pi minus pi over 2. So that is 2m pi minus pi over 2. I can write 2 times 3k plus 1 pi minus pi over 2. That is 6k pi plus 2 pi minus pi over 2. I can write 6k pi n plus 3 pi over 2. Divide by 6. So x is k pi plus 3 goes pi over 4. If you use the second one, that 4x. So 4x is 2n pi plus pi. Now I can write 2 into 2k pi plus pi. That is 4k pi plus pi. So x is again k pi plus pi over 4. Both are okay. So both should be okay. So in general, in exam, you just take one value, whichever is simpler. So this is simpler. This was simpler. And so I will use this one for the other example. So we got the general solution as x equal to k pi plus pi 4 simultaneous k element of G. Similarly, other example of inequalities in power, cos to the power 7x plus sine to the power 4x equal to 1. And you want solution in 0 to 2 pi both inclusive. This you want. Now, the first thing that you note when you see questions of this kind are unusual power, cos to the power 7x and sine to the power 4x. They just don't add up. But there is one thing that you can always note, that if we always have cos to the power 7x less than equal to cos square x. Why it is true? Because what you are saying is that you are saying that, okay, anything cos cube x less than equal to 1. So you are saying that cos x less than equal to 1. So this mod cos x less than equal to 1. So you can always write this, that this is this one. Similarly, sine to the power 4x less than equal to sine square x. That's true. Because in fact, this will reduce to sine square x less than equal to sine square x minus 1 less than equal to 0, and that is true. Or you can bring to that side. So it means that is correct. Now if that is the case, just add up cos to the power 7x plus sine 4x less than equal to cos square x plus sine square x equal to 1. So let's call it p. So you got p less than equal to 1. But p is given to be 1. Means all these inequalities, all inequalities must be equalities. Means cos to the power 7x is cos square x, and similarly sine 4x equal to sine square x. This all must be true. It means I want simultaneous solution of this system. Now, if that is the case, let's do the first system. It is cos 7x is cos square x. So cos square x, cos to the power 5x minus 1 is 0. That is cos square x is 1. And cos 5x equal to 1. Now you notice that this t to the power 5 equal to 1. T equal to 1 is the only real solution. Only real solution. So I will get from here that cos x equal to 1. And this I will get cos x equal to 0. I also have to solve this one, the second one, that is sine to the power 4x is sine square x 2, and I have to take intersection. But I notice that if cos x equal to 0, then sin square x equal to 1, and so it will be satisfied. Or say I can write this as sin square x cos square x equal to 0. So if cos x 0 is satisfied, if cos x is 1, then cos square x equal to 1, and this will imply sin square x equal to 0. So still this works. It means I can say that cos x equal to 0 and cos x equal to 1 satisfy both 1 and 2. This is 1. This I call as 1. So this I call as 1. This I call as 2. So that satisfy both 1 and 2. So cos x is 0. So cos x is 0 means x equal to 2n plus 1 pi over 2, and cos x equal to 1 means x is 2n pi. Now let me read the solution in 0 to pi. I want solution, all of solution in 0 to pi here, 0 to pi. So it means I can have from this family, n cannot be negative. So n we can write as 0, that is x is pi by 2, and nothing you can write here. If n is 1, then also all right, 3 pi over 2. So this is 2n plus pi over 2. X is 2n pi. I can put this 0, so this is 0, and this is also 2 pi. So it means in this case you are finding that it has got solution as 0, pi over 2, 3 pi over 2, and 2 pi. These are the 4 solutions that we get for this, that we get. We can also have done it using this one, this kind of thing. Sin square x equal to 1 and cos square x is 0. So I could have done this also. I could have solved 2 and then satisfied 1. So either of them will work. There is no nothing like this. So inequalities, was this example inequalities or extreme values? They are important. They are really important in JEE mains as well as advanced. So always keep them in mind. So okay, so that's all for today. Let us stop sharing and then okay, so that's all for today. So let me meet you again tomorrow.